In this channel we will be designing footing for Revit software for structural modeling from 1-story building to 200 floors. All formulas are programmed for easily exploration for various parameter to derive the footing size and rebars details. After some exploration of higher building, we found out the bottom bars might using bundled bar because the spacing of bars less to minimum spacing of bar as per code, and isolated footing become wrap foundation with RC piles. We have separate design calculation of wrap foundation design but almost similar to isolated footing design. The recorded history of structural engineering starts with the ancient Egyptians. In the 27th century BC, Imhotep was the first structural engineer known by name and constructed the first known step pyramid in Egypt. In the 26th century BC, the Great Pyramid of Giza was constructed in Egypt. Structural design is the methodical investigation of the stability, strength, and rigidity of structures. The basic objective in structural analysis and design is to produce a structure capable of resisting all applied loads without failure during its intended life. A structural designer designs, develops, and supervises the construction of new buildings and bridges, or extensions to existing properties or other structures. They review and update construction drawings as well as communicate project problems and flaws to managers. There are three methods of structural design, such as working stress, limit state, and ultimate load method of structural design. These design methods are used for reinforced concrete as well as steel structure design. Considering this is the suspended beam, slab in first floor, second floor up to top floor. Considering also the maximum factored vertical and lateral forces as per code or actual forces. How are you? Here you can input the value of tributary area, number of floor, then approximate dead load and live load automatic calculated with factor and all design calculation for your easy checking. If we try 150 floors with load tributary of 5 meter by 5 meter, with assumed design parameter, the size of square footing will be 13.8 meters and depth is 2.325 meter. To check in one way shear is OK and check the two-way shear is OK. Main bars is 249. If the actual soil bearing capacity is not suitable, it is recommended to put reinforced concrete piles under the footing to meet the required soil bearing capacity. If we try 100 floors with load tributary of 5 meter by 5 meter, with assumed design parameter, the size of square footing will be 11.28 meters and depth is 1.925 meter. To check in one way shear is OK and check the two-way shear is OK. Main bars is 163. Number of 25 mm diameter bottom bars both ways with the spacing of 43.55 mm. If any are not sufficient to resist the imposed loads. If we try 75 floors with load tributary of 5 meter by 5 meter, with assumed design parameter, the size of square footing will be 9.78 meters and depth is 1.675 meter. To check in one-way shear is OK and check the two-way shear is oak. Main bars is 122 number of 25 mm diameter bottom bars both ways with the spacing of 54.39 mm. If any are not sufficient to resist the imposed loads, we will check the formulas and RCD codes, although I love it. Dead loads include the self-weight of structural members, such as walls, plasters, ceilings, floors, beams, columns, and roofs. Dead loads also include the loads of fixtures that are permanently attached to the structure. Dead load is 35316 kN for 150 floors, assuming it is interior column with tributary area of 5 meter by live load is that can change over time, such as when people are walking around in a building. Anything in a building that is not fixed to the structure. In this example we have live load of 10767.01 kN. See also kilogram conversion for visualization. This example we use number of floor 150 meters, with tributary area of interior member of 5 meters by 5 meters. You got it? We do it this funny animated to bring attention. How about you? We'll assume that the floor load is 4.79 kN per square meter or kilopascal. And we have slab on grade thickness is 150 mm. The depth is 4 meter. Assume the thickness T is greater or equal to 800 millimeters. The compressive strength of concrete varies from 2500 psi, 17 MPa, to 4000 psi, 28 MPa, and higher in residential and commercial structures. In our example is 25 megapascal or meganewton per square meter. The yielding strength of reinforcement is 415 megapascal. We will assume the ultimate bearing soil capacity is 1000 kN per meter square. There are some method to determine the soil bearing capacity, such as presumptive analysis, analytical method, plate bearing test, penetration test. Of the required soil bearing capacity of the building not meet in actual, we can place reinforced concrete piles and can calculate it in foundation piling design. Assumed diameter of bar is 25 mm. If we adjust this value, the size of footing and rebars is adjust also. If we try 150 floors with load tributary of 5 meter by 5 meter, with assumed design parameter, the size of square footing will be 13.8 meters and depth is 2.35 meter. To check in one-way shear is OK and check the two-way shear is OK. Main bars is 150 number of 32 mm diameter, bottom bars both ways with the spacing of 59.4 mm. If any are not sufficient to resist the imposed loads, we will check the formulas and RCD codes, although we can check it in structural software, but we must understand. First, the theoretical manual approach. If the actual soil bearing capacity is not suitable, it is recommended to put reinforced concrete piles under the footing to meet the required soil bearing capacity of the building. The unit weight of concrete is 23.544 kN per cubic meter. Considering soil bearing pressure, the KNA is equal to Q ultimate divided factor safety, so 1000 divided by 3 equal 330. Nominal soil bearing pressure is equal to 333.34 kN minus 4.79 minus 23.544 times 0.15 for slab on grade pressure minus 20 times 3.2 for soil pressure above footing, so on so forth, so the Qn equal to 242.19 kilopascal. The factor load equal 1.4, dead load equal to 49442.4 kN. The combination factor load is equal to 1.2, dead load plus 1.6 live load is equal to 59606.416 kN. Then the ultimate soil bearing KNO equal to factored load over B square, KNO equal to 59606.416 over 190.44 equal 313 kilopascal or kilonewton per meter square.